everyone, I hope all of you are doing good, and today we are going to learn about electric charges and fields in one video. Yes, so this is a crash course video on electric charges and fields, and we are going to cover all the theory, all the concepts and few numericals as well. However, if you are looking for detailed derivations and more numericals, please refer to the link which is given in the description section. We have made detailed videos on electric charges and fields. Some of the topics that we are going to cover in this video are Coulomb's law, electric field intensity, electric field lines, electric flux and Gauss law. Let's get started. The lesson on electric charges and fields is like a movie where we have many different characters and these characters keep coming one after another. So the first character that's going to come into picture is electric charge. A few things that we already know. What is electric charge? It is a property of matter that causes it to experience an electrostatic force when near other electrically charged objects. Let's look at few examples. Suppose this balloon, you bring this balloon near a wall. Do you think that you will be able to stick the balloon to the wall without using Fevicol, adhesive or any sellotape? Of course not. But now you take the same balloon and rub it on a towel for some time. And after that you bring the same balloon near the wall and it sticks to the wall. What is this? Is this a magic? Not really. The balloon gets electrically charged by rubbing with the towel. Let's look at another example. These are some bits of paper. You take a plastic comb, bring it near these bits of paper. What happens? Nothing. Now you take the same comb and comb your hair for some time. After that, you repeat the same thing. Bring the comb near the bits of paper and this time you see that the bits of paper are dancing. That's because they get attracted towards the comb. Why? Because the comb here is electrically charged by rubbing with your hair. Electrically charged could be positively charged or negatively charged. Now, what do we mean by positively charged? Now, when an object has excess of positive charges, it is positively charged. That's quite obvious, right? So, therefore, an object loses electrons to become positively charged. In a similar way, an object gains electrons to become negatively charged. Now, we also know that like charges repel, as in positive, positive, repulsion, negative, negative, repulsion. Whereas the unlike charges attract. So, positive, negative, attract. There are many different ways by which objects can be charged. The first method that we are going to discuss is rubbing. So, charging by rubbing works for insulators, that is those objects which doesn't allow electricity to pass through them. Now how? Let's take a look. So here we'll again take the example of the comb which got electrically charged just by rubbing with the hair. Now that means in this case transfer of charge took place. But the question is, how did the transfer of the charge take place? As in the electrons move from hair to the comb or from the comb to the hair. Who loses electrons, who gains electron, and what decides that? That is where triboelectric series comes into picture. Now this series is, as you can see, it is a list of objects which tells us that which of these objects have a tendency to lose electrons and become positively charged and which of these objects have a tendency to gain electrons and become negatively charged. In fact, if you look at this list, all those things which are towards the top, they all tend to lose electrons and become positively charged, and those towards the bottom are the ones which tend to gain electrons to become negatively charged, and those which are kind of at the middle are kind of neutral. For example, paper, cotton, steel, wood, they are kind of neutral, right? So now in this particular scenario, we are rubbing two objects. One is human hair and plastic, which is here, right? So as a result, we see that human hair is on the top side of the series, whereas plastic is towards the bottom. That means the transfer of electrons will take place from human hair to the comb. So the comb will gain electrons and as a result, the comb will become negatively charged. The process of charging by rubbing happens only for few specific pairs of materials. Do you know why? Because in this process of rubbing, very limited number of electron transfer happens, because only those electrons get transferred which are less tightly bound to the nucleus. So therefore we need an electronic configuration that should support this. Therefore only those elements which have that suitable electronic configuration will be charged by rubbing. Now, very important point, charging by rubbing doesn't happen in case of conductors. Try it out for yourself. If you repeat the same experiment that we did a little earlier, just replace the balloon with a metal key. What happens? No matter how many times you rub that key on the towel, it never sticks to the wall. Why? Because this is made up of metal, the key is a metal, and metal is a good conductor of electricity, and therefore it conducts all the charges, and there are no charges on the surface of the metal. The second method of charging is by contact or conduction. Now what happens in this is, when an uncharged substance is brought in contact with a charged substance, it gets charged. So that's the concept. Now let us take a look at how this charging happens. Now let us suppose this is a negatively charged object, and let us suppose this one is an uncharged object. Now what happens when I bring this uncharged object close to this charged object? What happens? So inside this uncharged object, separation of charge takes place. Since this is negatively charged, so what happens? All the positive charges come towards this end and all the negative charges go to the other end. That's because opposites attract, right? So the positive charges start coming towards this end. Now gradually, when this uncharged object comes in actual contact with this negatively charged object, what happens? These excess negative charges move into the uncharged object. So as a result, so the negative charges move into this object. So what happens? This uncharged object becomes negatively charged. So we can say that in conduction, or the process of conduction charges the uncharged body with the same kind of charge. That means if this object is negatively charged, so it will charge the uncharged body negative. Similarly, let us suppose that if this charged body would have been positively charged, in that case, when an uncharged body comes in contact with it, in that case the positive charges flow into this body, and as a result this body becomes positively charged, right? So that's the concept. So conduction से जब भी चार्जिंग होगी तो अनचार्ज्ड बॉडी में उसी टाइप का चार्ज आएगा जिस तरह का चार्ज चार्ज्ड बॉडी में है. अगर चार्ज्ड बॉडी नेगेटिवली चार्ज है तो अनचार्ज्ड बॉडी भी नेगेटिवली चार्ज होगा. अगर चार्ज्ड बॉडी पॉजिटिवली चार्ज है तो अनचार्ज्ड बॉडी भी पॉजिटिवली चार्ज होगा. The third method of charging is by induction. So in induction, the uncharged object doesn't really come in contact, but it comes close to the charged object. So again, let us assume that this is a negatively charged object and this is an uncharged object. So what happens as this uncharged object comes closer to this negatively charged object, so separation of charge takes place inside. As a result, all the positive charges, they kind of settle over this surface of the uncharged body. And we all know that whenever we talk about the concept of static electricity, these are those charges which kind of reside on the surface of an object, right? So that ways we can say that in this case, this particular object gets positively charged. So we can say that induction charges the uncharged body with the opposite kind of charge. So that means if this would have been positively charged, in that case this would have got negative charge. Let us now look at some properties of electric charge. First is additive property. So what do we mean by additive property? The total charge on a body is the algebraic sum of all the charges located anywhere within the body. Second, conservation of charge. In an isolated system, the total charge of the system always remains the same. Now, transfer of charge may happen, but the net charge within the system is always constant. For example, if we talk about the process of charging of the comb by rubbing it with the hair. So in this case, the total charge before must be equal to the total charge after. That means the total charge of the comb and the hair before rubbing should be equal to the total charge of the comb and the hair after rubbing. So that is what is conservation of charge. Quantization of charge, a very important property of charge. What do we mean by this exactly? Now, whenever we say that this object has some charge, what do we mean? We mean that that charge is basically the charge of all the electrons which are present in that object. For example, if I say that this object has charge Q, so that actually means that Q is equal to NE, where E is the charge on one electron and N is the total number of electrons in that object. In fact, all possible charges in this universe exist in this form, that is Q is equal to NE, and this is called quantization of charge. In fact, quantization of charge talks about the discrete nature of charge. Charge which we often see as a continuous property actually exists in discrete forms. Let us look at this scenario. If I ask you, what is this red thing that you see? What would you say? You would say that it seems to be a straight line, right? But now, when we go deep into it to analyze what exactly it is, what do we see? We see that it is actually many red cars which are, standing one beside another. So what happened? Our perspective changed. So when we were looking at the same thing from a very far away distance, I would say at a macroscopic level, it looked like a straight line. But when we went deep down and went inside it to see what it is at a microscopic level, we found that it was not a straight line, rather it was a collection of many different cars. In a similar way, when we talk about charge and when we look at it at a macroscopic level, it seems to be continuous, because we often say, right, the charge on this object is 5 coulombs, the charge on the surface of this object. So it seems as if, okay, charge is all over and it is a continuous thing, right? But actually, when we look at it at the microscopic level, we see that it is discrete in nature. So if we say that a particular object has this much charge, that actually means that it has the total charge of all the number of electrons that it has is this much, right? So basically it is discrete in nature. But in any of these cases, quantization cannot be ignored. So at macroscopic level also, it seems as if the discrete nature is lost, but actually the discrete nature is not lost. And obviously at microscopic level, the quantization cannot be ignored. So quantization of charge is universal.